Welcome back to the GCSE Maths Pro YouTube channel. Today's video is a summary of bounds, where we will first go through what upper and lower bounds are in the first place, then we will look at some harder bounds questions with calculations and the ones that start by saying by considering bounds. And then finally we will just touch on error intervals because it is a topic that slightly overlaps with this one. So our first question here is, a number, x, is rounded to one decimal place. The result is 16.2. Write down the upper and lower bounds for x. So x was originally, I'm assuming, a longer number than this. It had more digits than just 16.2. They've looked at it, they've rounded it to one decimal place, and then after that point we get 16.2. So if you have a think about it, we're basically saying, what is the lower limit, I guess, bound or limit is kind of the same idea. What's the lower limit or the lowest possible number that 16.2 could have been originally for you to still round it up to 16.2? Because a lower bound is below, isn't it? So we would have rounded it up. What's the smallest version of this number that it could have been that we would still have had to round upwards to 16.2? And then for the upper bound, we're saying, okay, what's the biggest number it could have been that I would have still rounded it down to 16.2 when looking at just one decimal place? So we're looking for a lower number and a higher number than 16.2. Now, you don't have to do it this way, but if you're finding it hard to think about it, I tend to visualize it with a number line. I would just draw a little number line, doesn't have to look nice or anything. Put the 16.2 in the middle, whatever number it is they've rounded. Now, they've said they've rounded it to one decimal place. So what I'm going to do in that case is write down a number that is one decimal place lower. So what I mean by that is one below 16.2 is 16.1, isn't it? We're looking at that one decimal place there. One below is 16.1, and then one above is 16.3. Now, those aren't the upper and lower bounds, right? Because obviously 16.1 is a different number that I could round down to. 16.3 is a number I could round up to. So it's not those, but just do that. Then you just go halfway. So halfway between here and halfway between here. Your lower bound's obviously on the left. Halfway between 16.1 and 16.2 is then going to be 16.15, isn't it? Now think about it. If you saw that number and they said round it to one decimal place, you'd definitely round it up to 16.2, wouldn't you? So that means that anything 16.15 and slightly more would always round up, wouldn't it? Then for the upper bound or the upper limit, halfway between 16.2 and 16.3 is 16.25. Now this is the bit where obviously you kind of go, well, technically, if I saw 16.25, I'd round it up to 16.3. I know that. But what we're saying is basically 16.24 and then 99999 to infinity. That, if you saw that number there, you'd round it down, wouldn't you? Because you'd be looking at the 4 and go, right, I need to round down to 16.2. So we basically just say, to summarise the 9s that go on for infinity, just write it as 16.25. Okay, I know technically if there was a 5, you'd round it up, but in this case, we're saying these two are the same thing. So what we're saying is anything between 16.15 and 16.25, doesn't matter how many decimals there were originally, it doesn't matter. As long as they're between those two numbers, you would have rounded it to 16.2. So our final answers are, the lower bound is 16.15 and the upper bound is 16.25, just for simplicity's sake. I know that it's technically 16.24999999 forever. We're obviously not going to write down that many 9s, okay, so just write down 25. So you can visualize it like that if you like, and that will work for any kind of thing. So if you're rounding to one decimal place, two decimal places, rounding to the nearest 5, 10, 100, whatever significant figures, that works. Or you can just start to look at it and go, well, I know you can have a look here. It's just kind of like, in this case, one decimal place, you half that. Okay, the other way to look at it is, okay, one decimal place, that's like 0.1, isn't it? That's one decimal place. You can look at it as, okay, I need to take away half of that, which is 0.05, or plus half of that to get the upper bound. In this case, you can see we've taken away 0.05 to get 16.15, we've added on 0.05 to get 16.25. You might find that easier, you might find that more complicated. It just depends. You've got the two options. Either just draw a little sketch here to visualize it, or you can just go, right, okay, whatever they've rounded it to, I'm going to half that and add it on and take it away. So let's do another question so we can practice both of those methods again. So we have here a number n is rounded to the nearest 5. The result is 490. Write down the upper and lower bounds for n. Okay, so again, if I use my method of drawing the number line, the number they give you goes in the middle, so 490. Then I go, okay, what have they rounded it to? The nearest 5. So I'm going to do, in this case, 5 below, so that would be 485, and 5 above, which would be 495. And then just remember, you do have to go halfway, because obviously 5 below would have been, rounding it to a different number. 5 above would be rounding it to a different number. So you have to go halfway. So halfway between 485 and 490 is going to be 487.5. And then halfway between 490 and 495 is 492.5. Those are your lower and upper bounds. Because let's say if I had anything slightly above or including 487.5, I would round it up to 490, wouldn't I? And again, technically, the nearest 5, if I were to round 492.5, I'd round it down. Now, if you're looking at it in terms of what we said previously about doing half of what they've rounded it to, the nearest 5 is obviously 5, right? So we're going to add or take away half of what they've rounded it to. So in this case, you can plus or minus. In that case, 2.5 is half of 5, isn't it? So you can look at it that way if you don't want to draw out this whole number line. It's up to you. So you can see I've obviously taken away 2.5 from 490 to get the lower bound, and I've added it on to get the upper bound. So our final answers are the upper bound is 492.5 and the lower bound is 487.5. Okay, so you've got those two options, the pink option or the green option. Okay, so now we've got one which is rounded to a certain number of significant figures. These ones tend to seem a little bit harder or a bit more complicated, but they are technically kind of the same thing. So in this case, I would encourage you to use the number line method just so you can visualize it a little bit easier. So we have here a number y is rounded to 3 significant figures. The result is 2.79. Write down the upper and lower bounds for y. Okay, so in this case, they've said 3 significant figures, which means we're really focusing on that third significant figure, aren't we? So the 9 is what we're focusing on. So if I draw my number line, obviously put the 2.79 in the middle, and then you go, well, what's, 1 below, 1 above? Well, it's not 3 significant figures below, 3 significant figures above. What we're looking at is that third significant figure, 1 below that and 1 above. So 1 below that would be 2.78, and 1 above would then technically be 2.8, and I'll put a 0 there just so we've got 3 numbers. So you're looking, in terms of significant figures, whatever the number of significant figures is, you're looking at that one. So in this case, the third significant figure is the 9, and I want 1 below and 1 above. Okay, so that's the bit that can be a bit tricky. From here, once you've got that, then it's just the same as before, isn't it? Go halfway. So the lower bound is 2.785. A lot of the time you are kind of adding on an extra 5, but not always, so just be careful. The upper bound is then 2.795. Again, I know that technically if you were to round this to 3 significant figures, you would round it up, but as we've said, we can't put down 2.794 and then 9 forever. We can't write down enough 9s for it to be mathematically accurate, because technically the number of 9s goes to infinity. So we're going to just write it simply as 2.795. Okay, so that is your upper bound, 2.795, and your lower bound is 2.785. Okay, so the last few questions are actually going to be a little bit further than just working out upper and lower bounds. We're then going to be using the upper or the lower bound in a calculation. So here we have the length of a square is 12 centimeters to the nearest centimeter. Work out the upper bound of the perimeter of the square. So the actual calculation we want is the perimeter, and we're just using the upper bound of the perimeter. So what you need to work out in this case is, okay, first of all, how do we work out the perimeter of a shape? Well, obviously we're going to add together all of the sides. But we want to work out the upper bound, which means the biggest possible perimeter. So in that sense, okay, I'm going to add together all of the sides. I need to work out first, do I need the upper or the lower bound of the side length to then be able to calculate the biggest possible perimeter? Okay, don't work out the perimeter first and then do the upper and lower bounds. You have to work out the upper and the lower bound of, in this case, the length, and then use it to find the perimeter. So because I want the biggest perimeter, logically I would need the biggest length. wouldn't I? So that means I need to just know the upper bound of the length. I don't need to know the lower bound. So if I quickly draw this, I've got 12. I want the upper bound, so the nearest centimetre, one above, would be 13, and then halfway. I don't need to worry about the lower bound. If you want to work it out, that's fine, but you don't need it. Halfway is obviously 12.5. Okay, so I'm going to assume that all of my sides are 12.5, because it's a square, right? So we've got 12.5 all round the square, and now all I need to do is just work out the perimeter. I've already done the upper and lower bounds part. Now it's just the perimeter. So it's technically 12.5 added together 4 times, isn't it? So I'm just going to do 4 times 12.5, which should give us 50 centimetres for the upper bound of the perimeter. And that's it. So if you have questions where you've got calculations involved, or formulas or anything like that, where it's not just work out the upper or lower bound straight away, you actually have to do a calculation. Work out the upper or the lower or both bounds first, in this case of the lengths of the sides of the square, before then inputting those numbers into the formula that's relevant. So in this case it was the perimeter. It could be area, it could be just a random formula that they give you. But definitely work out the upper or the lower bounds, whatever you need first, then input those numbers into the formulas. Now, this one again, it's just a more complicated formula. We've got now 3 numbers. And not only do we have divide, we also have a minus, we have squares as well, but mostly the complicated part is the divide and the minus, isn't it? So calculate the upper bound of A when, and we've got V, U, and S. So upper bound of A. What am I going to need? Well, I know from what we've just said in the previous one, to get the biggest possible answer when I'm dividing, I'm going to need the biggest possible numerator divided by the smallest possible denominator. And the fact that it's then times by 2 doesn't really make any difference. So 2 times, I need the smallest possible value of S. That's quite straightforward. So the lower bound of S, okay? Now the numerator, I need the biggest possible numerator. Okay, so looking at the subtract, again, the squares don't really matter because it's just squaring the same number, right? It's more so the subtract. V and U, to get the biggest possible answer, I want to take the biggest V and subtract the smallest amount from it, don't I? Smallest U. So I need the upper bound of V, which obviously then is technically squared, minus the lower bound of U. Okay, so it is a bit complicated to figure it out, right? But just kind of sit there and think about it logically before you start looking at numbers. To give the biggest numerator, I want to take the biggest number and minus the smallest number from it, don't I? That'll give me the biggest numerator. And then, to give me the biggest answer for A, I then want to divide that by the smallest S in this case. Okay, so once you figured out that, I would recommend writing this down before you put any numbers to it, just so you know what you're doing. And now we've got 3 of them. I don't really want to have to work out all the upper and lower bounds for all 3. I could just work out one for each of them. So for V, we've got 42.0, correct to 1 decimal place. Now I want the upper bound of V, so that's 1 above, so 42.1. Again, don't think that that's going to be 42.5 because it's not. It's looking at 1 decimal place. So the upper bound is 42.05. Okay, that's another complicated one to figure out, and they do tend to choose kind of harder ones like that as well to trip you up. So that's V. Okay, U, we want the lower bound, which is, we've got 7.04, correct 2 decimal places, so I'm looking at the 2nd decimal place, which is the 4. I want the lower bound, so 1 below is 7.03, and then halfway. Lower bound is 7.035. There we go. That's U. And then finally, I'm going to want the S, which I'll put over here. So we've got 75.5, correct to 1 decimal place again. We want the lower bound, so 1 below 75.4. And as we said, halfway. 75.45. Okay, so that's S. And now it's just putting it in your calculator. Obviously, make sure you write it down as well in the formula, but we're going to put this in the calculator. So we've got the upper bound of V, which is 42.05. Don't forget that this one is squared, so that's squared, minus the lower bound of U, which is 7.035, again squared, over, and then 2 times by the lower bound of S, which was 75.45. And now we just put everything in the calculator. Okay, and there's our answer. We've got 11.389, which I'm just going to round in this case to Let's go with just 2 decimal places. We've got 11.39. Again, it should tell you in the question if you need to round it. If in doubt, just write down all the decimals, okay? So what's that? That's A, isn't it? A is equal to 11.39. In this case, we've rounded it to 2 decimal places. Okay, and that's it. That's just a more complicated version of the previous question. So the questions we're going to look at are the ones where you might have seen it says by considering bounds, and then it just says calculate the value of something. It doesn't actually tell you whether to calculate the upper or the lower bound. And as you can see here, it says the value as in one answer, not two. So in this case, when it says by considering bounds, calculate the value, singular, of something, it basically means we need to work out the upper bound of, in this case, f, and the lower bound, and then come to a decision using a suitable degree of accuracy as to one final answer. Okay, so you're considering both of the upper and the lower bounds, and then you're going to choose a final answer. So normally these are quite a few marks because you've had to do both the upper and lower bounds, and it's in some form of calculation. So in this case it says calculate the value of f to a suitable degree of accuracy. Don't worry about the degree of accuracy yet, we're just going to deal with working out the bounds first. So they've given us the formula, f is equal to p times a, and they've given us values for p and a, which are obviously correct to certain measurements. So in order to find f, I need to times these two values together. Let's say I want to work out the lower bound of f first. So the lower bound of f is the smallest possible value of f, isn't it? I need to work out, based on my calculation, which is multiply, do I need the smallest possible value of p, or the biggest, or do I need the smallest possible value of a, or the biggest, right? So I want the smallest answer when I times together two values in this case. Timesing together two values to get the smallest answer means I'm going to need those two values to be the smallest in themselves, aren't I? So that means I need the lower bound of p times by the lower bound of a. So you have to make that decision yourself. Do I need the upper bound, the lower bound? Do I need a mixture? In this case, to find the lower bound of f, I need both the lower bounds of a and p. And in the same way, if I want to find out the upper bound of f, to find the biggest possible value of f, I want to times together the biggest possible values of p and a, the upper bounds of p and a. So I need to work out the upper and lower bound of p and a first. So for p, I'm going to write down the number, which is 5. So we've got 5 newtons per meter squared, correct to two significant figures. So that means I need to look at the second significant figure, which in this case is the 0. So we want one above and one below. So one below is 4.9, one above is 5.1, and obviously remember, we're going halfway. Because I'm working out the upper and the lower bound of f, I'm going to need both the upper and lower bounds for p as well. So lower bound is 4.95, so halfway, and the upper bound would be 5.05. So I've got those. Then let's just quickly do a as well. So in the middle, we've got 2.19 meters squared. Now this is to three significant figures, which means I'm looking at the third number, which is 9. So one above and one below. So one below is 2.18 and one above is 2.2, and I'll put a 0 just to make it look the same. And then obviously halfway. So lower bound is therefore 2.185 and the upper bound is 2.195. So now I've worked out both of these, I can just literally put them into my formulas and straight into the calculator. So the lower bound of f is multiplying together the lower bounds of p and a. So the lower bound of p, let's label this, shall we? This is p and this is a, isn't it? So the lower bound of p is 4.95 times by the lower bound of a, which is 2.185, and then I'll just chuck that in my calculator. Now I'm just going to write down all the digits. If there's more than this, maybe just write down 4 decimal places for now, but in this case I'm just going to write them all down. So I've got 10.81575. 575, okay, and then we'll do the same for the upper bound of f, means I need the upper bounds of p and a, so we've got p, which is 5.05, and a, which is 2.195. Again, just chuck it in your calculator. So here I have 11.08475. Okay, we found the upper and lower bound of f. Now, we're coming back to this part here. It says calculate the value, just one, okay, with a suitable degree of accuracy. So I'm going to look at both of my answers, 10.81 and then 11.08 and just look at what do they both round to. Okay, I know I've got a lot of decimals here, but just kind of look at it really straightforward. They both round to 11, don't they? In the case of if I were to say round it to two significant figures or round it to the nearest whole number, they would both round to 11, wouldn't they? And that's the number that I'm therefore going to choose. So I'm going to write here at the end, therefore, my final answer is F is 11. Now, F is newtons, which I'll probably give you, but anyway, 11 newtons in this case. And you have to normally give a reason for your answer. So what they mean by the reason is, why did you choose 11? You just say, because to whatever you rounded it to, and so in this case it's the nearest whole number, isn't it, or to two significant figures if you like, to the nearest whole number, they both round to 11. That's kind of your reason. Okay, so whatever you end up rounding it to, obviously the numbers are different in each question, right? You might round it to the nearest whole number, you might round it to one decimal place, you might round it to a certain number of significant figures. Whatever it is, they should both round to that, okay? They should both round to the same number, and you just say your reason is because when rounded to this, they both are the same. A lot of students find it quite tricky to see how error intervals is its own topic compared to upper and lower bounds, but also the fact that sometimes it does seem like basically the same thing. So we're going to go through two different types of questions. One type is where error intervals is effectively the same idea and the same concept as upper and lower bounds, and then the other type where it is slightly different. So first of all, interval is just a range. So your answer should always be in the format of kind of like an inequality. What's the smallest value it can be and what's the biggest value it can be? You write it as a range with inequality symbols. Sometimes the exam will give you the answer inequality already written there. You just have to add the numbers. Sometimes it will be blank and you have to figure out how to write it down. So the first type of question we're going to go through is a question where it's very, very similar and pretty much the same concept as upper and lower bounds. So for example, we have here a number, x, is rounded to one decimal place. The result is 2.7. Write down the error interval for x. So what that means is we've got a number, we don't know exactly what it was originally, but we know that when they rounded it to one decimal place, it gave them 2.7. When we're rounding to something, the original number might have been slightly lower, or it could have been slightly higher. We don't know if they rounded up or if they rounded down. So this is where it's very similar to upper and lower bounds because we're trying to find effectively what's the largest value it could have been to still be rounded down to 2.7 and what's the smallest value it could have been to have been rounded up to 2.7. So we are effectively finding the upper bound and the lower bound. We're just going to write it in the format of an error interval. So 2.7, if we think about it to one decimal place, we're looking at 7. And the way I normally do it when I'm looking at upper and lower bounds is I tend to draw a number line to visualize it. I put 2.7 here and we go, okay, it's to one decimal place. So what's one above, or one decimal place above is 2.8. What's one below? 2.6. Now obviously if it's 2.6, you're not going to round it to 2.7, are you? So what we actually want is halfway between these two. So for example, 2.65, anything 2.65 or above would round up to 2.7, and then 2.75. Anything 2.75 and below would be rounded down. The smallest value it could be is the 2.65, so it can be equal to that or greater. So we have to put the symbol facing towards, obviously, our x. In this case, just copy the letter that they've given you, but it could also be equal to that. However, the next inequality symbol can't have the equals symbol. So I am going to use 2.75. However, what I'm saying here is it's anything less than 2.75. Not literally 2.75, but anything less. This is how you write the interval. The bottom one will always be less than or equal to, and the top one will always just be less than. Use whatever letter they've given you, and then you have to figure out what's the smallest possible value, what's the largest possible value. So in this case, it is basically upper and lower bounds, isn't it? This is the lower bound, this is the upper bound. We've just written it in an interval format. That's where it overlaps with upper and lower bounds. If you have something that is rounded to whatever, decimal place, meters, millimeters, centimeters, whatever it is, that is the same as upper and lower bounds. The next few questions are going to show you how it actually can be different. to upper and lower bounds, okay? This is the other type of question. So this might be a new word for you. If you have a look here, you might not recognize one of the words, and we're just going to go through what that means before we actually work out the error interval. You can see it's still written in the same way, okay? It's still the same interval, but it's a different type of question. So a number, y, is truncated to one digit. So what do we mean by truncated? A lot of people probably haven't ever seen this before. If you get this in the exam and you've never seen it before, well then there's not a lot of hope, is there? So truncated just means we had a number and we literally at some point we just cut off the rest of it. So it wasn't rounded to one digit. It was just whatever was there, it was cut off after one digit. This is still 6 in terms of 6 in the units column, right? So we don't know what the number was. For example, this is just an example. It might have been 6.2357. We don't know. What truncated is they just went, oh, one digit, okay, that's a 6, cut off the rest. It could have been 6.9999 forever, but truncating, you would just cut it off. So it's not rounded up or down. The 6 was 100% there. We just don't know what followed the 6. Okay, so in this case, it's not like it could be 5 point something. No, it was definitely 6. We just don't know what came after that. Now, like I said, it's one digit. It's not like that was 6,000 or something. It is 6 in the units column. So it's 6 point something. So if you have a question like this, where it's been truncated, or you get the idea that the number was just cut off after a certain point and you don't know what followed it, the number they give you will always be your smallest value. We don't know. It might have been 6.0. It could have been, couldn't it? And they cut it off. So 6 is your smallest value, okay? So whatever they've given you here in the question, that's going to be the smallest possible value. So at least that's quite easy. Half of the work is already done for you. But then trying to figure out, well, what was the biggest value? Like I said, it could have been 6.99999 forever, couldn't it? Now, it can't be 7 because we know for sure, the fact that it was truncated, we know 100% it started with 6. We just don't know what followed. So the maximum is technically 6.9 recurring, isn't it? 6.9 forever. But the same as before, we're not going to put 6.99. You can't write that many 9s. It's literally to infinity. And you can see we've still got the same inequality symbol. It's not equal to this value, but that's the biggest, as in just a little bit less than that. So in this case, obviously we know it can't have been 7. However, it could have been anything slightly less than 7. So that's why it's not equal to 7. We know that the number was somewhere between 6 and 6.9 recurring to infinity. So I'm going to use 7 for simplicity. So truncated is where they've just taken a number, they've cut it off after a certain number of digits. They haven't rounded up, they haven't rounded down necessarily, they've just cut it off. So we don't know what followed. This question is still the exact same concept as truncating. Okay, it's worded differently, and I've seen this a lot with Edexcel particularly, but the idea is still the concept of truncation. So we're still on that second type of error interval question. We've just worded it differently. So the number on a calculator display began 5.2 something. Complete the error interval. So what we're saying is if you imagine your calculator, it physically said 5.2, but we don't know what came after that. Could have been another 10 digits. We don't know what followed that, but we know for certain that this is what it started with. So the smallest it can be is that number, isn't it? 5.2. It can't be 5.1 something because we know for certain that we saw 5.2 on the calculator. We just don't know what came after the 2, if anything really. So the smallest is 5.2. Can be equal to that, it can be more than that, but up until what point? Well, effectively at the point where it then becomes 5.3, because again, we know it was 5.2, it definitely wasn't 5.3. However, it could have been 5.299999. Again, we're still into that recurring 9 into infinity, aren't we? So it could be equal to this, but therefore the biggest value is 5.3 here. It's not equal to 5.3, but it's just anything less than 5.3. So it's somewhere between 5.2 and 5.3. Okay, so if you get this second type of question where it's truncated, or they've said calculated display, or you feel like the concept is basically truncating, the number they give you is going to be your smallest number, and then you just figure out what then is the biggest number. So thanks for watching this video. If you found it helpful, make sure to like and subscribe. If you would like to look at any of the full videos from anything that we've touched on in today's video, they will all be linked down below.